Hello everybody. This is lesson 2 of the lecture International Capital Markets. I will discuss slide 30 to 47 of chapter 1, how capital markets work. In this section I will discuss people's behavior towards risk. I would like to start with the discussion of the results of the classroom experiment. You had the possibility in 3 different experiments to choose among 2 different options. In the first experiment, option A offered a sure payment of €3, while option B offered an uncertain payment of €5 or €0 with equal probability. The expectation value of the uncertain payment of option B is 50% times 3 plus 2 plus 50% times 3 minus 3, which amounts to €2.5. So this is the expectation value, the value we can expect on average if we choose option B. In this version of the experiment, 6 of you preferred option A, while 2 preferred option B, as I've noted here. So, who is right, who is wrong? Well, there is no right or wrong in this case. Your choice depends on your personal degree of risk averseness. You might argue that the expectation value of option A is larger than the expectation value of option B. What is the expectation value of option A? Well, it is 100% times €3, so it is equal to €3. However, there is a 50% probability that option B provides a higher payment than €3. If the fortunate variant realizes, you will receive a payment of €5. So, if you are a little bit more risk tolerant, you might therefore prefer option B. The only case where we could determine whether it is right or wrong to prefer option B or A is when it is sure that everybody prefers a higher payment over a lower payment and the maximum payment offered by option B is lower than the sure payment of option A. But in our experiment, this is not the case. The highest payment of option B is €5, which is definitely higher than the certain payment of option A. So, it is in the last instance a question of your personal preferences or your personal taste if you choose option B or option A. Now let's turn to experiment 2. The expectation value of option B is now 50% times 3 plus 2 plus 50% times 3 minus 2. So the expectation value is now a little bit higher. The expectation value of this is 3. Hence, on average, you will make no loss if you select option B compared to option A. However, if the unfortunate variant of option B realizes, you will receive less than the certain payment of option A. And when the lucky variant of option B realizes, you will receive more than the certain payment of option A. Consequently, it is again not possible to say what decision is right or wrong. However, as the results show, now more people seem to prefer option B. We have now 4 people which still prefer option A, while 4 people now prefer option B. Which could perhaps be explained by saying that in this experiment the payment in the unlucky case of option B is now €1 and not as before €0. Okay, so let's now have a look for experiment number 3. Here the expectation value of the certain payment is again €3, while the expectation value of the uncertain payment is again a little bit higher as before. The expectation value of option B is 50% times 3 plus 7 plus 50% times 3 minus 1. And the result of this is now 6. So €6 is the expectation value of the uncertain option. On average, you will gain if you select option B compared to option A. However, if the unfortunate variant of option B realizes, you will receive only €2, what is less than the €3 of option A. And when the lucky variant of option B realizes, you will receive €10, which is of course more than the certain payment of option A. Consequently, it is again not possible to say what decision, option A or option B, is right or wrong. As the results show, now, however, all of you prefer option B, which could be explained by saying that in this experiment the payment in the unlucky and lucky case of option B is now significantly higher as before, such that the expectation value is significantly higher as before. Now, what does this experiment show? Perhaps we can draw the following conclusions. Most people prefer a certain payment over a risky payment. At least most of you. A risky payment is accepted only if it includes a premium which is high enough. In economics, this premium is called a risk premium. The magnitude of this risk premium differs individually from person to person. However, the existence of a risk premium shows that people generally do not like risk. They are willing to accept risk only if they are compensated for the risk by a higher payment. In economics, we call this type of behavior being risk averse. We have derived this result that people are risk averse with the help of an improvised laboratory experiment. However, we find also a lot of hints that people are risk averse in financial market data. For example, this diagram compares the yearly returns of German government bonds, the green line, with the yearly returns on German corporate bonds, the red line. Over the years 1999 to 2010. On average, the return of corporate bonds, the red line, is higher than the return on government bonds. This can be quite plausibly explained by the higher risk of corporate bonds. Private companies which issue corporate bonds can go bankrupt, while it is much less likely that the German government will go bankrupt. Consequently, the risk of an investment in corporate bonds is higher. Interestingly, the diagram reveals that the risk premium on bond markets varies over time. At the beginning of the year 2004, in this region here, the risk premium was close to zero, while in the course of the year 2008, around here, the risk premium became suddenly very large. How can we explain that? Well, we need additional information. Starting by the year 2003, around here, the German economy experienced a business cycle upswing. Consequently, the risk for private companies of getting bankrupt became smaller, such that more risk-averse investors were now also willing to buy corporate bonds. As we will see in chapter 2, the more demand for bonds, the higher their price and the lower the effective interest rate on bonds. So this explains why the difference between returns on corporate bonds and bonds of the German government became nearly zero around this time here. To the contrary, in the course of the year 2008, the so-called subprime crisis happened. And in September 2008, the big American bank Lehman Brothers went bankrupt. So the default risk of an investment in corporate bonds became higher. As a result, investors sold corporate bonds and their returns became again larger. So in financial markets, the risk premium varies if there's information that the risk varies, which makes sense, of course. Let's now turn to the question why people demand a risk premium. Why are people risk averse? Our self-experiment and empirical data from financial markets clearly show that people are risk averse and demand risk premiums for risky investments. Now the question is, why do people behave in this way? Is it kind of irrational fear to be risk averse, or can we explain it with standard assumptions of microeconomics? The next slides show the standard microeconomic explanation for risk-averse behavior. Standard microeconomics derives the explanation from a quite plausible property of the utility function. This property is called decreasing marginal utility of consumption. The next slide gives an explanation of this property. This is a typical microeconomic utility function. It assigns every consumption level measured on the x-axis or abscissa to a utility level measured on the y-axis or the ordinate. Of course, personal utility is hard to measure. However, as we will see, we can derive from such a utility function a couple of properties which can be empirically assessed. Given this utility function, a consumption level of 0 cookies implies 0 utility, since the function starts here in the 0 point of the diagram. A consumption of, let's say, 16 kilogram cookies would provide accordingly a utility level of 12. According to the shape of the utility function, we observe that it gets flatter and flatter the more kilogram cookies we consume. It's relatively steep here at the beginning, and then the slope gets really flat, nearly horizontal around here. So what does that mean? The first kilogram cookies provides, according to this shape, a relatively high increase of utility from 0 to 1 kilogram additional cookie consumption, and we have an increase of nearly 4. So this is the additional utility of the first, provided by the first kilogram cookie. The second kilogram cookies provides an additional utility of roughly 1.5 utility units. And the third kilogram cookie would provide, roughly spoken, 1 additional unit of utility. So we have 4, 1.5 and 1. The additional utility provided by additional consumption gets smaller and smaller. This is what we call decreasing marginal utility of consumption. As it seems, an increase from the 19th kilogram cookies to the 20th kilogram cookies will cause 0 additional utility or 0 marginal utility, since the curve is flat here, it's horizontal here. How do we interpret this property of the utility function? This property of the utility function is, I think, quite plausible for most consumption goods, because the first unit of cookies, hamburgers, beer, TV sets, smartphones, and even Ferraris typically provide more additional utility than the 19th or 20th unit of these goods, since the first unit satisfies a more basic need than the 19th unit. This is what we call, as already mentioned, decreasing marginal utility. As we will see, it implies that people with such a utility function are risk averse. To understand why, let's apply such a utility function to our second experiment. The expected payment from the certain option A is €3, what results in a utility level of 9.5 utility units. The expected utility from the uncertain option B is 12 utility units times a probability of 50% plus 4 utility units times a probability of 50%, what is equal to 8 units expected utility. Hence, expected utility of option B is smaller than the expected utility from the certain payment. Consequently, a person with such a utility function would always prefer the certain option A over the uncertain option B. If we take a closer look on this result, we can discover that the reason for the lower expected utility of the uncertain option is the stronger change of utility in case of an income loss compared to the case of an income gain. The reason for this asymmetry is the property of decreasing marginal utility of the utility function. In case of the uncertain option B, money income falls by €2 or grows by €2. In case money income falls by €2, a utility loss of 5.5 results. In case of money income growth by €2, a utility gain of only 2 units utility results. Consequently, the asymmetry of the utility function caused by the property of decreasing marginal utility causes the lower expected utility for the uncertain payment, even in cases where the expected income level is the same for option A or option B, namely €3. This becomes obvious if we compare such a utility function with decreasing marginal utility with a utility function like this that has the property of constant marginal utility. In case of a utility function with constant marginal utility, the utility loss in case of an income loss of €2 would be equal to 4 utility units. And in case of an income gain of €2, the utility gain would also equal 4 utility units. As a result, the expected utility from the uncertain payment is equal to 10 plus 2 times 50%, 6 utility units. Hence, expected utility in case of a certain payment would be equal to expected utility in case of an uncertain payment. So we can conclude that people with a constant marginal utility function would be risk neutral, not risk averse. The fact, however, that most people are risk averse and financial markets demand a risk premium for compensation of risk means that most people have a utility function with decreasing marginal utility. Consequently, decreasing marginal utility causes the utility loss in case of an income loss of €2 to be larger than the utility gain in case of an income gain of €2. Therefore, in the case of decreasing marginal utility, expected utility of a certain payment is always lower than expected utility of an uncertain payment, if the expectation values of the payments are equal. And therefore, in case of an uncertain payment, the income gain must always be larger than the income loss in order to make people accept the uncertain payment, which means a risk premium must be paid. Obviously, this is the case in our third experiment, as the following diagram shows. In the third experiment, the income gain of the uncertain payment is €7, which results in a total income of 10, what is transformed by the utility function into a utility level of 15 units. So compared to the certain payment, we would have a utility gain of 5.5. In case the income loss realizes, the income loss of €1, we would end up with an income level of 2, what is transformed by the utility function into a utility level of 7. So the utility loss would now only be 2.5. The expectation level of utility in the uncertain payment case would be 15 utility units times 50% plus 7 utility units times 50%, which equals 11 utility units expected utility. So this level of expected utility is now larger than the utility from the certain payment, which is 9.5 only, and therefore an individual with this utility function would prefer the uncertain payment in experiment 3. In this example, expected utility from the uncertain payment is higher than the expected utility from the certain payment. The result is a person with such a utility function will now accept the risk of the uncertain payment because compensation is paid for this risk in terms of a higher expected utility level. Let's summarize our findings with the help of this diagram. A normal person will typically have a utility function with decreasing marginal utility, which is a concave function like this red curve here. A person with a utility function with constant marginal utility, which results in a straight line like this green curve here, would be a person which is risk neutral. And a person with a utility function with the property of increasing marginal utility would have a convex utility function like this blue one. Such a person would be a risk lever. However, a person with increasing marginal utility is hard to find in reality. That's what we know from empirical experiments. As the following digression on slide 45 to 47 show, not only humans are risk averse, but also simple plants. Consequently, risk averseness seems to be a dominant evolutionary strategy. So much for this lesson. In the next lesson, we will discuss how we can use financial markets to get rid of risk.